Okay, so before we cover the two-dimensional arrays, let's cover this part in the book about these structures. This is a really interesting part because this is the precursor to object-oriented programming. Remember that we talked about array is that in an array in Visual Basic you have to have the same data type, right? You cannot mix and match data based on a certain type like string or number or boolean types in an array. You have to have the same type only, and that is the restriction for most strongly typed languages, including Java and so on. So one way to solve the problem is to use what's called arrays or structures. Okay, so a structure is like an object that allows you to have different types of properties to that object, right? If you think of a ball or of a person, for example, you have the or any object in the 3D space. You think of a car has different colors or different speed. You have different wheels and so on. So all those are properties that describe that object, and the structure is kind of same in that nature. Okay, so you can have an array of, let's say, students, and then that students usually, if you have the usual array, it could be contains only names, right? You cannot have names and phone numbers and email all in one array. You can't do that. So to solve that problem, you could build like 3 or 4 different arrays. We talked about the parallel arrays because they share the same index. But the other solution is to have the structure here. So a structure will look something like this if you have it here. So if you think of this as a structure of nations, or if you think of as students, same thing, then inside the structure, so everything you see in blue there are keywords in Visual Basic, and that you can have like the name of that nation, for example, or what continent is it in, and also the population and its area. So you can see different data type can be added to that structure. And when you want to access those data, you will use what's called a dot notation to get there. So it will be like nation dot name, nation dot continent, and so forth. Okay, so in this way it looks just like an array, except you can have different data types. Okay, so if you want to use this as the student example, you can have like structure and a student. So for each student you have a name, you have ID, you have a major, and you have an email, and so on, right? So different data type can be added in there. And this example, so for example, you have a structure, then that structure can be treated like a data type. Okay, so as you can see, we declare a country as a variable, and the data type usually would say as string, as integer, as boolean, and so forth. So now you can declare that object or that variable as that nation or that student structure. Okay, so in a sense you can create your own data type. Okay, it can contain any type of data and you have in there. That's entirely up to you, and so it gives you that really nice flexibility there, which is pretty powerful in this sense. And again, this is the same concept that is used in object-oriented programming. Okay. So now when you declare a variable called country of this data type nation, then this object or this variable country can access all of these data in here by using the dot notation. So it'll be like, country dot name will give me the name of what this is. And so country dot continent will give you that continent that it belongs to. And so you can also assign values to those parameters, those variables. So country.continent is assigned the the continent of Europe, right? And so forth. So this is very, very powerful. Here is another example, the same. So you have a country of nation. So the nation has, we saw in the structure, it has the name, continent, population, area. And this line here is a string. A string that has 4 records. Okay, you remember we did the split last week. You can split a string. Once you do the line split, then usually that is assigned to a single dimension array of that same type. In this case, it will all be converted to just characters of strings. Even though these are numbers, this is actually converted to a string, right? It's a string of numbers. So now this data array here will have 4 elements in there, and the 0 position will be China, the 1th position will be Asia, and so forth, right? So it will be index of 3, because 0, 1, 2, and 3 has 4 elements. And then once you have that, then you can go ahead and reassign the data stored in this array to the country.name, country.continent, and so on, right? So if you were to read this, information from a text file or from a database table, then you have to do this process, right? Read it into a string, and then you would split it into an array first. After that, you can get each record easily that way and assign to the structure there. So, so the word country here will actually contain all this information, and as you can see, they have different data types. Okay, very useful, and so that would be much better than if you have 4 different arrays for all these 4 different types. Okay, so that is the structure, and we'll do some examples of this as well. Same thing here. Text file. Yeah, we'll do some text file a little bit, because it's a good transition to next chapter. And then let's go right into the I'll go right into the 2 arrays. Where is it at? Right here. So a 2-dimensional array is really just it's like a rectangular array. Sometimes that's it's called. A rectangular array is an array with the same number of size of rows and columns. Well, I should say, the number of columns and rows don't have to match, but the columns have to be the same for every row. So it's like a regular table. Okay. So here's an example of that. Again, that table or the array has to also store the same type of data. So last week we learned about the single-dimensional array, where it is just a 1 row of data, or 1 column, however you choose to look at it. And then now, if you want to add another row to that record or that array, then that makes it a 2-dimensional, because you have a table now. Okay, so that alone makes it a different type of array. And again, it's stored the same data type. You have a column and a row to deal with. So this is the usual, or the syntax to declare a 2-dimensional array. Dim is the same as before, right? The array name, and then inside the paren, you need to provide both the row and column. So the first number, the m, is always the number of rows, and then the second number is always the column. Okay, it's just by convention, the rule of arrays is always structured that way. Okay, when you print it out, you print the data out, it doesn't matter which way you go. You can print column-wise or row-wise, doesn't matter. But in terms of its structure and how it looks inside the the memory or in the computer, the first number is always the column. So you think of that as the the row. So that would be like what? The so the y, right? X coordinates. Okay, and the second is the column, and then if it's a 3rd dimension, we're talking about the z the z index, right? Not z index, the z system. So you have it's a 3-dimensional object or a table, which we're not going to do. You can go to 4th dimension and 5 and so on. It gets complicated. Okay, so these are also your upper bound index. Okay, we talked about upper boundary before, right? So the upper bound for the row will be m, upper bound for the column will be n in this case. And you get the number from using the get upper bound paren into 0 or 1. I mentioned that last week also. The 0 only gives you the first number here, which is the row, or the it doesn't matter what you call it. If it's a one dimension, it's just the last index of that array. And then if you want to get the column array index, that will be the upper bound of 1. Okay? And so here we have, for example, another array, and you can use variable names to index those as well. So with the ith row, the jth column, and so it'd be like the 0th row or the 0th column will be the upper left corner of the table, and you move along each of those rows and columns by increasing or decreasing the I and the j. So here's another example of how you can actually initialize your array. You can do it this way by supplying the length, the size of the array first, and then after that you would do like array 0, 0, assign equal to a number or some data, array 0, 1, and so on. Right? You can do that, or you can do the other way that we did, which is similar to the other one, except now again you don't put any numbers in here. You just put a comma to separate between the left, the column and the row, and then that column and rows will be determined based on the number of data you have. So notice in here we have a pair of curly braces outside. Okay, that represents the entire array, and the inside that you have a comma separated, right? And between each comma you have a group, another curly braces of some data. Okay, so this is your, if you look at this first comma here, this entire record here, whatever you put in here is another array. So you can put, like, for example, if it's an integer, you put like in here 1, 2, 3 in here, so 3, and then here put like 2, 3, 4 in here as well. So each of these comma here, see here, this is one row, this is the second row, third row, and so on. What's inside each of these row here will be your columns. So if you have like 1, 2, 3 inside here, it's a 3 column, and they have to match. Okay, you cannot have like 3 columns here and still you have 2 here, right? Or 4 over here. So the column have to match the row. Of course, they can be any row you have, which is 1 row or 100 row, doesn't matter. Okay, so if you look at this, it's really you can say that this is a two-dimensional array is really an array of arrays. Okay, you have another array or a list of other arrays is nested inside another array, so you form this two-dimensional array. And if you talk about three-dimensional arrays, you have an array of arrays of arrays, right? It just get complicated that way. So to get that, you will put inside the row here another curly braces inside. You have another array inside. So you put it inside other arrays. So here is an example of a typical two-dimensional array, right? Not talking about the name here, but if you look at this data here, so this table here from 0 here to 0 here, you see it's a table of some data, and so this table has 1, 2, 3, 4 rows. So the index for that first position will be for 3, right? It's 3 minus 1, 4 minus 1 to get the max index for the row. And it has also 4 columns. So it's a 3 by 3 in the index, but really it's a 4 by 4 table. Okay? So if I ask you to construct a 4 by 4 table, then that means it has a total of 3 columns and 4 rows. 4 columns and 4 rows. Then the index is make sure it has to go only from 0 to 3. Okay, so don't confuse by the array size versus the index numbers. And here to construct this table here, the easiest way is to fill in with those numbers, right? So as you can see, this versus this, right? This is much harder to visualize. It's really hard to see because you don't understand which row is it, which column is it in. So you can separate that and break it down into like a table structure. You can see that, right? You can so you can see this is your first row, and this row here you have a paren here, and then curly brace here to construct your first row. your first row has this many columns, so 1, 2, 3, 4, right? You put those numbers in there, and then this comma separates the first row. You move on to the next row, and you curly braces, and then supply the for record for data, and then you move on down until you reach the end of that row. And again, that will determine the number of the size of the array, right? It will know that you have that many rows and that many columns to put it here. Okay. And if you want to access each of these elements in here, then you just basically now use the index or the subscripts for the row and column to get them out. And if it gets really complicated, then it's always good to visualize it or put it into a table like this, so you know exactly where the number is. If you want to get this number 2786 here is actually from the 0, 1, 2 index for the row, and then 0, 1 index for the column, so it'll be 2, 1, okay, to get this 2786 value. Okay? Yes? Oh, do I? Go either way, but usually, yeah, it's the row. Yeah, you can traverse either direction. That's fine. But right, so again, make sure this is the row. It's the column. Okay, so the row would be like row 0, row 1, row 2, comma, and then column 1, column 0, column 2, or call it 0, 1. Okay, this is the standard way. But if you wanna read out from the column first, that's fine. Okay, so to get the upper bound of the R and S, or the row and columns, here I guess you just put the array name dot get upper bound, and we learned about 0 before. 0 is just the first dimension. Okay, and sometimes you hit the first dimension, or you get the row index, and so on. So you can think of this as the first dimension, which is 0. The second dimension, which is 1, and you have a third one will be comma in the third dimension. Okay, and that would be represented by the number you put inside here. 0 is the first dimension. The 1 is the second dimension, which is the column. Okay, and you have a third comma. A third one will be the third dimension. So it'll be a 2 here, and they'll give you the max index of here, the size of that row, the size of that column. Okay. On size array, you have just like this. You don't supply the value there, right? It's blank. And again, this will be redeclared, resized later on once you populate data into that array. So the redim array here, maybe we'll see how that's done, but I'm not really critical about the redim here. The redim means redimension your array. So if you, for example, sometimes maybe, well, let's backtrack a little bit. And remember that when you declare an array with a certain size, okay, that is already fixed size. If you create an array of 3 elements, then that's already you're stuck there. 3, you're done with that. You cannot change the size of that anymore. But it does allow you to use this keyword redim to resize the array. Okay, so if you resize the array, suddenly you have some data already, but you know what? I want to trim my array down to just 2 elements, or two records. Then you will redim it. You issue the keyword redim, and you give it a new size. Okay, either a 1-dimension or 2-dimension, doesn't matter. But you want to be careful, because if you do that, then whatever the size is, if the size is much larger than what you already have, then that's fine. It will retain whatever you have plus the additional new spaces. If you shrink it, if you have less than what you have, then whatever is outside of that new dimension will be deleted from your memory. You will lose those data. Okay. And I think if you don't, well, actually, no, I should backtrack a little bit. If you don't put a preserve, Okay, if you just resize it, then yeah, it will lose all the data, and your array will be resized. And then if you want to preserve, then yeah, you want to put the preserve keyword in there so that whatever is not chopped off from that new size will be retained. If you change the size to be much bigger than what you have, then all the data will be retained. If you shrink it, then whatever is out of that boundary will be chopped off, will be truncated, but the other data will be retained as well. So if you don't really care about data anymore, you just want to change the size, then you don't need a preserve there. Okay, just wipe out everything and change the array size to something else. And you might ask, why would you do that? Can't you just create a new array? It's kind of same thing, right? Because if you do a redim and you would change the array size, initially it's a 3 by 3, and I want to change that to a 3 by 4 now. So why don't we just create a new array and you don't have to worry about the new data because it's all wiped out anyway, right? And the reason why you may do this is because let's just say you have an existing data or program that somewhere down the line or in other people's code or maybe somewhere in your code you're already using that array name called array name. Okay, and if you change it to a new array, then the name has been changed, and so therefore it will not work in the other people's code. Right, so that means you have to tell your other programmers to go ahead and change the new array now to this array. The other one has been deleted, right? So that will be a problem. So if you just resize it, but you still retain the original array name, then your code can still work. Okay, so that is the benefit of resizing an array, and by keeping the same array name. Okay, so that's one of the main reasons why. So here is how you would populate in a two-dimensional array with a text file. As you can see, you have inside that distance.txt file, you have 4 records, and each record has 4 columns, right? Or 4 data, or 4 fields, we call those. If you think about it in terms of a database or the table, then each column is really called a field. Okay. And so on. So and then when you read the end of this first row here, it will actually issue a carriage return, like a hard return, to move on to the next line. So when you issue this text file into Visual Basic, it will know where to stop. It will read this first line until it reaches the end of that line. It will read that carriage return, and it knows that that's the end of that record. And then it will move on to the next one, and then you read it again, and it will go that way. Okay, if you don't issue a carriage return, then this is a single long string of text go all the way across here. Okay, so that's how texts are structured in a text file. And the same as we saw earlier, we declared an array of two-dimensional array of 3 by 3. That means we have 4 elements, 4 rows, 4 columns of the double type. And then we'll read this file that has these records in here. So it reads the first row has 4 fields to this array. It's a one-dimensional array. So row of nums 0 will give you this entire row of data. It has a comma in there. So to break it down into the two-dimensional, you need to break each of these into their own separate field. So you have to go through another process by splitting the string again, right? So for each row in there, you would split it, and once you split it, you have another array created here called data array. And then from the data array, you can now grab each of these numbers. So data 0, data 1, data 2, 3, and so on. You read that into the new table, and then you loop through the entire data to do that. So it gets a little bit complicated, but once you get the algorithm written down and you understand the process, then you can achieve that by doing something like this. Okay, so this is just to read a text file, and then you break it down to a database. Array. Then you break each array element into its own. You split the with the comma. Again, you have to know what's inside this text file. If they don't use a comma, if it use like a pipe symbol or just a white space or something like that, right? Then you have to make sure you use the correct separator here. This is the delimiter. Otherwise, it won't work. Okay. The link, we will explore this when we go into chapter 9. Actually, chapter 10, 9 or 10, we'll deal with databases because this is really related to database. But if you have not used databases before, then this may be new to you. If you have used before, then this will look very similar. Although it's kind of different because in Visual Basic, with link, you actually reverse the order of how a query can be called. Usually in a standard SQL statement, you will provide the select statement on the top and not the bottom here. So it would say select num from the table, right? But here you say from this table select num. It's reversed in the SQL statements. But that's that part. I want to see if what's in this slide here. This one here has a little bit more information about the two-dimensional array. It's going to tell you what, if you were to access this table here, what the subscripts will look like. Okay, so here to get this text, all that equals, you're going at 3, 1. So you go again 0, 1, 2, and 3. And then the 0th column, the 1st column, and you get that text out, right? So this is the title of the song by Josh, and then the release year for that song or album, whatever that is. Okay? And then so that's an example how you will actually code it inside Visual Basic. Will look something like this, which you saw earlier, where you would code using those numbers, except now it's a string. So again, the first row has 3 columns, and again the number of columns have to match. That's important about two-dimensional array here. The row doesn't matter, but the column has to match if you have more than 2 columns. I mean 2 rows. And of course you can also have unmatched columns as well. That's called a jagged array or a non-squared array or non-squared table. You can do that as well, but the way you do that is a little bit different in terms of syntax. But usually two-dimensional arrays are square, especially in Visual Basic. So because now you have 2 dimensions, and when you iterate through the array, if you want to print them out, you have to use a nested loop. Okay, otherwise it won't work. You might get it to work, but it'll be very difficult to get to work. And this is the typical way or the typical algorithm to iterate or to loop through a two-dimensional array. So you have the outer loop. The outer loop here will loop through each row. This example is you're going through each row, right? So the first row, which is 0, and then for that 0, you loop through the columns for that row, and then you print out the value or your assigned values to that position. Either way, you want to assign values, or you iterating, or you printing them out. You still need to have a loop this way. So you can go row-wise. You go row by row. Or you can go by column. It doesn't matter how you do it. You can swap the 2 here, and you put a column outside and then the row first. So that way, the row will actually climb much faster because it's internal, and then the column will be much slower. So actually, you go on column through column instead of row by row. Okay. So in terms of printing out, you have that option. But when you read it, it's always still going to be row and column. Okay? And again, this is how you get the upper bound for the 0 for the row and the column. So upper bound 0 is the first index, 1 is the second index, okay, the maximum index. So in this example here we have a states of 49 rows index, which is 50, and then 3 index here for the column, which is 4. So this is a 50 by 4 table, okay. And to get this number 49, if you use the states dot get upper bound 0, we'll give that for you. And then get the number 3 is use the 1 inside the get upper bound method here. Okay, so just to make sure you know the difference between those two and when to use them. So the size of this table is really a 50 by 4 table. So we saw how you can actually traverse or iterate or loop through the two-dimensional array using 2 loops, the outer loop and the inner loop. And you can also use the for each loop. We talked about that last time as well. You use the for each to loop through the array for a single dimension. For a two-dimensional array, you can still use that too, which is fine because it still deals with the same data type. So for the for each, it will still work. The only thing is that with the for each, you cannot control which direction it goes. It's going to go from top, right, and then to the bottom. It's going to go by row wise only. So it's going to go every row by row, and then row column all the way down. Whereas if you use the loops, you have control. You can read either direction. Okay, so so here this is the same thing, right? Two-dimensional array using the nested loop. For each, for example, here you have for each month and the month array, you just print everything out. You don't really care about what position they are in, as long as you print everything out from the table, from the top left all the way down to the bottom right. Okay, that's how you do it, and that's what is used for. Then be it. Otherwise, you want to change the direction how to read it, then don't use the for each loop. Let's see what this one says. It's probably referring to this table. Yeah, this table here. So if you look at this table here, so the first row is Jan and then has 31 days. Second row is Feb, 28 days. So we have 1, 2, 3, 4 rows and 2 columns. Okay. If you want to print out using the for loop or the do loop here, this one here you go by row first, right? Row wise. Read the first row, which is this row here, and then you assign the second index for the column, and you first start from 0, 0. So you print out 0, 0 for January. And then you go and you loop through the internal loop here. Column will be 1 now. So you print 0, 1 just over here. So you print out Jan 31. And you go to the next row, Feb 28. That's what you get this result here. Jan 31, Feb 28, and so on. Okay? This one here, you are reading column wise. You're going to read a column first, so you go column by column. So that means you're going to print this column first, and you move to the next column, and so on, right? So that way the order is different. So I'm reading the first column, which is 0, and then I also assign the row to also 0, and then and when you print it out, it's going to be 0, 0. But now, as you can see, the loop here, you actually increasing the row, so the column is still at 0, but now row jumps to 1. So now row goes down here, and you read 0, and then be 1, 0, 2, 0, 3, 0, right? As you print the entire column here, when you're done with that, then you X out of the row loop here, you go to the column, and it jumps to the next column, and you start over again. Okay, and that's how you get this result here. You print out the months first, you get the days out of that. Okay. Now if you were to use the for each loop, you'll get the same result as this one. Okay, so this is the column of the row wise. This is the same as if you were using a row first in the column inside your internal loop. You get the same result because it's going to read from top left to the bottom right. You go this way, just like that, the usual way. So if your data looks like that, if you have like 4 columns and 100 columns, it doesn't matter. It's going to print everything out from top left to the bottom right. Okay, and so that way you don't have much control. If you want to print out something like this, then this one doesn't work that way. Okay, even if you have a 3-dimensional array, it's still the same thing. It's going to print everything out from the top down to the bottom right. Okay, so it's quick, kind of nice and easy to print everything out, but it may not be that useful. Okay, we'll do some of these examples later on. Let's see. So I think that one's done. Then what is this one here? Yeah, this is kind of the same thing. This one here talks a little bit about a jagged array, and it's an array that have different size. And we're not going to do that, but I'll show you what that looks like. But the syntax is a little bit different. So for example, if you look at this slide here, notice that you have a table with uneven column size, right? It's a three row table. The first row has 3 columns, the second has 4 columns, and the third has 2 columns. Okay, it's in the same array. And this is what's called an uneven a non-rectangular array or a jagged array, because you can set the size differently. So for example, when you were to set this in the code, it will look a little bit different. So you have here like a double pair of paren outside of here versus you have a comma inside, because this is the row, this is the column. Because the row will be how many rows we have, the column can be different size. Okay, so that's why they separate them out this way. So each row can have different column size. But we're not going to do that in this class because it gets confusing. Okay. So let's go ahead and do some examples. Just